Okay, so for this figure, we have a 5 newtons force act on a stationary 25 kg box lying on a rough surface. After 4 seconds, we find out that the speed of the box becomes 2 meters per second. So there is a change in velocity from rest 0 to 2 meter per second in within 4 seconds. Thus, it telling us that the box is accelerating. So since the box is accelerating, it means that in order to solve this question, I'm going to apply Newton's second law, which is summation force equal to ma. So question A, I need to determine the friction force on the box. So since the box is moving, so means that I'm going to calculate the kinetic frictions. And then B, the coefficients of kinetic friction between the box and the rough surface. So the coefficient of kinetic frictions is represented by symbol mu k. So to solve the questions, I'm going to follow the problem solving strategy. First, I need to draw the FBD, free body diagram, in order to identify all the forces that are acting on the box. So let's start with the FBD. So for this box, there is the apply force acting on the object. So we redraw the apply force. So this is the apply force F. Beside that, the box have mass, so for sure it have weight downwards. And then the box is in contact with the surface, so we are going to have normal force acting upwards. And then because the surface is rough and due to the apply force 500 newtons, so this box is accelerating rightwards, so we are going to have kinetic friction acting leftwards. So Fk. So this will be the 4 forces acting on our 25 kg box. Second step, I'm going to choose the axis. So I treat this one as my x-axis. And here will be my y-axis. So after I choose the axis, I can see obviously my normal lie along the y-axis and the weight is lie along the y-axis as well. The friction Fk is lie along the x-axis, pointing leftward, but the external force F, 500 Newton, is acting at a particular angle, 50 degree from horizontal. So this force, actually, I can break it down into component X and also component Y. So the component X for F will be F cos 50 because it's at this component X is attached to the angle, and the component Y will be pointing downward, whereby it will be F sine 30, F sine 50, sorry. Why? Because this component, why we use sine? Because this component is opposite to the angle. So after I have break down all the forces into its component, then now I'm going to apply the Newton's law in order to calculate the frictional force on the box. So since this object is accelerating, there is a change in velocity. So I'm going to apply Newton's second law, summation force equal to ma. So the object is accelerating along the x-axis. So I'm going to apply Newton's second law, summation force equal to ma. So I'm going to have summation force along the x-axis equal to ma. So how I'm going to write the equations for Newton's second law correctly? So first I identified the directions of A. So the directions of A is rightward. So I treat the directions of A as positive. So I'll notice that along the x-axis, I'm going to have F cos 50 in the same directions as A and Fk pointing opposite to the directions of A. So I'm going to have F cos 50 minus the force that opposite to A is Fk. So minus Fk equal to ma. So then I'll solve the question in order to calculate the Fk. So I want to calculate Fk. I know the mass of the object is 25 kg, but then I didn't know about the A. So I need to calculate the A. So how I'm going to calculate this A? So because I know the change of velocity, whereby the velocity change from 0 to a final value of 2 meter per second in within time of 4 seconds. So I can calculate the A using the kinematic equation V equal to U plus AT. So after 4 seconds, the final velocity is 2, initially at rest, so 0. So the time taken for the changes is 4 seconds. So I'll get the acceleration is 0.5 meter per second squared. Then I put it back into these equations. So F is, the applied force is 500 cos 50 minus Fk equal to the mass of the box is 25. So the acceleration we calculate is 0.5. Then I can calculate the kinetic friction force acting on the box. It will be around 308.89 Newton. Then for question B, I need to calculate the coefficient of kinetic friction between the box and the rough surface. So the coefficient of kinetic friction actually can relate with the friction force, whereby Fk is coefficient of kinetic friction multiplied normal force. So in order to calculate the coefficient of kinetic frictions, I already know the friction force is 308.89 Newton, so I need to calculate the normal force. So how I'm going to calculate this normal force? So if we refer back to the FPD, our normal force is lie along the y-axis. Our normal force is lie along the y-axis, and then so our normal force is lie along the y-axis, and then the box doesn't have any motion along the y-axis. So for the y-axis, we are going to apply Newton's first law. The summation force along the y-axis will equal to 0. Why? Because there is no motion along y-axis. The box is only accelerating along the x-axis, okay? So it doesn't have any motion along vertically along y-axis, so the summation force component y equal to 0. So refer to all the forces along the component y. I have normal force pointing upwards, so I have positive n. Then you will notice that along the y-axis, you have F sine 50 pointing downward and weight of the box pointing downward. So we should have minus F sine 50 minus the weight of the box equal to 0. Then we put in the value. So the external applied force is 500 sine 50 minus the weight of the box. Weight of the box can be calculated using equation mg. So the mass of the box is 25. G is 9.81. The magnitude of G is 9.81, so equal to 0. So we will get the normal force is 628.27 Newton. So after I obtain the value of normal force, then I can calculate the coefficient of kinetic friction. So put in the value of Fk, 308.89 equal to the coefficient of kinetic friction, and the value of normal force is 628.27. Then I'll get the coefficient of kinetic friction will be around 0.492. So there will be no unit for coefficient of kinetic frictions because Fk divided by n, so the unit for Newton will be cancelled off. So we have obtained the value of friction force. Fk is 308.89 and the coefficients of kinetic friction will be 0.492.